Hello everyone. Once the initial setup is complete, we can now run the full RTL to GDS 2 implementation flow. Before that, I just want to export some of the path for our design configuration file. I am assigning it to CFG. So design GF180 new underscore design config.mk. Similarly, for ORFS, I am exporting its location and assigning it to ORFS. So it's FOSS tools bin then ORFS. This is the path. This is the location for the ORFS tool. Again, for OpenROAD, it's FOSS tools bin OpenROAD. Now we will type the make command to execute the entire RTL to GDS process. For this, you just type make platform GF180 flow variant base track option 90 design config, which is nothing but our design configuration file path. Star dollar CFG then ORFS, we have assigned it to ORFS. Just put inverted comma $10 and OpenROAD exe is OpenROAD. Now let's look at the command used to run the OpenROAD flow. So here I am using a make command to automate the entire RTL to GDS process. We specify GF180 as the platform, which means the design is implemented using 180 nanometer technology. Then the base flow variant is selected, which uses the standard setting for the flow. The 9 track option define the standard cell height used during the placement. Next, the design configuration file provide all the necessary input like RTL files and timing constant. We also give the path for the tools. ORFS is used for synthesis and OpenROAD is used handles the physical design stages. So with just this single command, the complete flow runs automatically, taking the design from RTL all the way to final layout. As soon as I run this command, the automated flow starts. As you can see, the first step is the synthesis stage, where RTL is converted into a gate level netlist. This is done by the Yosis tool. After synthesis, the flow continues through multiple stages automatically. This includes floor planning, placement, clock tree synthesis, and routing. For timing analysis, tools like OpenSTA are used during the process to ensure the design meets timing constraint. So all of these steps are executed sequentially without manual intervention. The entire process may take a few minutes depending on the complexity and size of the design. So once the flow is completed, we are able to see the final layout of our design. As you can see, the execution has now completed successfully and the full design flow is finished. Now we can move on to viewing the final layout of our design. To open the layout, we simply add a small option GUI_final at the end of the same make command. So once I press enter, the OpenROAD GUI launches, and here we can see the complete layout of our design. In this window you can observe different metal layers, via connections, and overall physical structure of the chip. You can zoom in, explore different regions, and clearly see how design has been implemented at the layout level. In the left side of the window you can see the display control. Here if you uncheck the layers, you can see how these metal layers are organized and connected to different instances. Along with these metal layers and via connections, you can also see different nets, for example signal nets, power nets, ground nets, then clock signals. Okay. Similarly, we have different instances like standard cells, macros, if macros is present in your design. Okay. You can also see the routing congestions. Okay. So you can see the highlighted more dark area represents the more routing congestion. Okay. Similarly, we have IR drop, placement density, okay, power density. So by uncheck these things, you can control the view of your layout.